Hi! In this video, we were learning about the ED painting process. This series of lessons is divided into several parts, ranging from basic to advanced knowledge. This video features the episode 1. Here is a practical example. When a factory produces a car, they have to conduct many quality tests, such as the vehicle impact durability resistance test. The problem is that it's fine when the car is new, but as the car gets older, the durability of the parts decreases. For example, resin, rubber, or even metal parts. So, how can we protect metal in the long term? Currently, the best method that car manufacturers are using is to apply a paint layer to create a protective coating on the metal surface, helping to preserve the quality of the metal for a long time. In fact, have you ever wondered why every house needs to be painted? In other words, how to protect your house from ultraviolet rays? The answer is simple: to reflect as many ultraviolet rays as possible. And this is achieved through the paint on the exterior of the house. At this point, you might be wondering what paint really is. So, let's move on to part 1. Paint definition. To give you a deeper understanding of what paint is, for example, I have a piece of material called a substrate, which can be made of plastic or metal. The surface is a layer of paint, so essentially, paint is a colored liquid or mixture applied to a surface, forming a polymer film. You may already know that paint is used for decoration, but in fact, paint has many other important purposes. Paint helps in decoration, enhancing the beauty of the surface of details. For example, with the same detail, you can use different paint colors to create products with different colors, such as red or even green. This diversity makes your product more accessible to a wider range of customers. Paint is not just for decoration. It also has another important function: protection. For example, when a layer of paint is applied to a metal surface, it helps prevent corrosion, thereby enhancing durability. Similarly, on cars, to resist oil corrosion. The paint is mixed with an additive that acts as an oil resistance agent. In addition, there's another effect that we rarely notice. Paint also has a functional purpose. For example, when you paint the walls of your house, it makes everything cleaner and easier to wipe down. Because paint serves such an important purpose, it must always be completed with good quality. However, to ensure this, paint quality testing must be conducted during prototype development, right from the initial stages of paint product or prototype development. Specifically, the following key aspects need to be tested: test appearance, color matching, gloss. For example, there are 2 suppliers, A and B, that supply components to factory C. Both A and B paint the components red color. Both A and B evaluate the paint color and determine it is okay. However, when the 2 products are delivered to factory C for assembly, the QC team immediately faces a problem that seems simple, but is actually difficult. A's red is 100% red, while B's is only 80%. Therefore, when the 2 parts are assembled side by side, a color mismatch occurs. It's similar to buying a car. If 5 cars are lined up side by side and the shades of green vary significantly, you'll immediately see that the car with the bad paint is the one that doesn't look good. Next, the paint's ability to withstand external forces is tested, such as with a pencil hardness test. Let's assume this is the substrate layer with the paint layer on top. Pencils of different HB hardness levels are used to rub against the paint to see how many HB levels it can withstand. And many other tests depending on the product's quality requirements. A typical example is that a product sold in the USA might be tested at -10 degrees Celsius. while in Vietnam it might be tested at plus 10 degrees Celsius. Why? Because in Vietnam, there is no snowfall, no sub-zero temperatures. Now I have a question. If paint is a polymer mixture, what exactly is inside it? This is where we come in part 2, the core components of paint. Take a can of paint and examine it closely under a microscope. You'll be surprised to learn that paint is made up of 4 main components. That's fascinating. The first component is solvent, the liquid medium that carries pigments and binders, making paint spreadable. In most cases, the solvent is water or deionized water. The second ingredient is binders, the film-forming agent that holds pigments together and makes paint stick to surfaces. The third component is pigments, which provide color and opacity. The fourth component is additives, which are small amounts of chemicals added to improve paint performance. Next, I will share more details about binders, also known as resin. Binders can be divided into carboxyl groups, which can lose a proton, so they become negatively charged. In other words, the paint carries a negative charge. Next is the amine group, which can accept a proton, so it becomes positively charged. In other words, the paint now carries a positive charge. Therefore, binders can affect ED production technology, which is why we need to use direct current. Next is pigment. As the name suggests, this is the substance that gives paint its color, whether you want red or green. It all depends on the pigment. Adjectives, for example, include the adjective anti-corrosion by oil. In short, these 3 substances dissolve in a solvent to form a polymer mixture. Understanding the composition of paint is the first crucial step in understanding the paint manufacturing process, why paint parameters need to be managed, and many other quality factors. After understanding paint, let's find out what ED paint is. ED paint, also known as ED coating, is essentially an abbreviation for electro-deposition paint, or e-coating. This is a coating applied using electricity to create a uniform, corrosion-resistant film, even on complex metal parts. Next, we will explore the most basic yet crucial aspect of ED paint, the ED painting principle. Let's say I have a metal part. I call it a metal part to apply ED paint. The metal part is immersed in a paint bath called an electro-deposition bath. The bath is filled with paint. Specifically, it consists of the 4 components we just learned about. First, there's the solvent. For ED paints, a weak acid is also added to the solvent. The acid neutralizes the resin to ensure water solubility, stabilizes pH levels, and controls film thickness for uniform deposition. The next factor is the pH level, typically ranging from 5.5 to 6.5. Next are the pigment, additive, binder, or resin components. Depending on the type of paint, it may be pre-mixed or you may have to mix it yourself. Therefore, mixing in the correct proportions is very important. For example, mixing too little pigment will result in a very light color, while mixing too much will result in a very dark color. We will learn more about this later in the section on. Parameter management. After everything is prepared, the electro-deposition bath is connected to a positive pole of power source. This causes the entire paint bath to become positively charged. Immediately afterward, the electro-deposition bath is also connected to a negative pole of power source. However, instead of directly connecting the negative power source to the metal part, For convenience in production, the metal part is mounted on a jig. And then the jig is connected to the negative pole of power source. That's why jigs are so important. They must be made of a good electrically conductive metal. This is why you must maintain your jig and design it correctly. We learn about jig design methods in the next video. In short, based on the ED painting principle, it is possible to create high-quality ED paint. Why is it called high quality? Because ED paint has 5 layers. That's right. It looks thin, but inside it's actually 5 layers stacked on top of each other. These 5 layers adhere to the metal surface, also known as the substrate. As for ED paint, it consists of the following 5 layers. The first layer is the pretreatment layer, also known as the phosphate layer. This layer prepares the metal surface and provides the initial foundation for adhesion. The next layer is ED primer. Acts as the primary anti-corrosion barrier, using electric current to ensure rust protection, even in hidden crevices. The third layer, primer or surfacer, helps smooth out surface imperfections and provides chip resistance against pebbles and debris. The fourth layer, the base coat, provides the vehicle's visual color, including special effects like metallic or pearlescent finishes. The fifth and final layer is the clear coat. This final transparent layer provides UV protection, weather resistance, and a high gloss shine. In other words, when you touch the paint, you're touching this clear coat. Furthermore, before creating the first layer, the pretreatment layer, a super thin layer of phosphate or zirconium, must be created. Therefore, essentially, there will be a phosphate or zirconium layer between the substrate and the pretreatment layers. In summary, each layer created plays a different and crucial role. Together, they form ED paint with 5 layers of paint, which is why it's considered a high-quality painting method widely used, especially on cars. However, not all 5 layers are always necessary. Depending on the required quality, only 2 or 3 layers may be needed. If you hear there are 5 layers of paint, do you think it's thick? Probably, right? The answer is no, because each layer is very thin, measured in micrometers. The thickness of each layer is shown in the illustration. You can refer to it for more information. Importantly, you'll see that the surfacer and clear coat layers are the 2 thickest. The thick surfacer layer provides a smooth finish and physical protection, while the thickest clear coat ensures aesthetics and long-lasting durability. Now I have a simple question. Paint materials have 4 components. So how are these 4 components distributed across 5 layers of ED paint? The answer is that from the pretreatment layer to the base coat layer, the main components are usually binder, additives, and pigment. Simply put, this is the color layer of the paint. The outermost layer, the clear coat, usually only contains binder and additives. It does not contain pigment, which is why it's called a clear coat. True to its name, it's transparent, allowing us to see the color layer underneath. Wait a minute, I'm very curious. Why can't I see the solvent component to find the answer? Let's delve a little deeper into the ED painting process. Normally, when the paint is first applied, this is called the pre-drying stage, and the solvent is still present. However, to dry the paint, there's a curing process lasting 1 to 2 hours. After curing, the solvent, being a liquid like water, evaporates under the influence of high temperatures around 150 degrees Celsius. Therefore, after curing, only 3 components remain on the metal surface, forming a polymer paint layer. So the knowledge I just shared is about the distribution of the paint components after curing, which is why the solvent component is no longer visible. Now, let's return to the ED painting principle. By definition, E-coating is a coating applied using electricity. So, does it use direct current or alternating current? The answer is that it uses direct current electricity. Why? Because electric current can create an electric field. Simply put, there's an invisible force of attraction and repulsion between the positive and negative poles of an electric current directed from the positive to the negative pole. So, when I place a binder molecule, a component of paint, into the electric field, it will immediately be attracted to the negative pole and adhere to it. Utilizing this principle, if I attach a steel component to the negative pole, such as a car frame, the binder will also adhere to the frame. If I place trillions of binder particles, they will all adhere to the car frame. Ultimately, this results in the car being painted. In short, the ED painting principle sounds simple, but in reality, its application requires many technological and technical elements. You'll see that factories producing ED paints have a massive management system. For example, they need parameter management, quality management, jigged tool part design, regular management and adjustment of pH and acid levels in the paint tanks, and many other activities. We will explore these in more detail later. Now, let's first understand the basics of the ED painting process in this part 4. Typically, there are 5 main steps to complete an ED painting process. Starting with preparing the metal part, the ED painting process includes the following steps in order: pretreatment ED painting, electro-deposition, ultrafiltration rinse, baking or curing, cooling, and inspection. Let's explore each step in more detail. You might be wondering why I included metal part here, even though it's not part of the ED painting process. That's because I want you to understand the secrets that no one else wants to share with you. The metal part is the component that needs to be painted. ED painting is only applicable to metal parts, remember this. Typically, metal parts are created using a stamping process. This involves taking a large sheet of metal and putting it through a stamping machine. The machine is fitted with a die, which cuts the sheet into smaller pieces. For example, a punch die mechanism punches through the metal sheet, resulting in the blanking material, which is the product that needs ED painting. The problem is that punching creates significant friction, so oil is often used for lubrication to reduce this friction. Therefore, the product often gets oily. Another factor is that the product is very susceptible to rust over time. You may already know the chemical formula. Iron combines with oxygen in the air and water vapor in the air to create rust on the metal surface. In addition, dust particles can also adhere to the surface of the metal part. If the metal part surface has oil, rust, or dust, it will result in low ED painting quality. To ensure high quality, oil, rust, and dust must be removed. To perform this cleaning, the first step in the ED painting process is the water rinse, established in the pre-treatment step to remove oil, rust, and dust. So, I have explained the oil and rust removal step. Now I will move on to the next step. Step 1. Pre-treatment. This is considered the most critical step, determining corrosion resistance. Generally, it aims at 3 main goals: cleaning the metal surface, creating a phosphate crystal layer for adhesion, and improving corrosion resistance. More specifically, it consists of several smaller steps, which I will share as typical steps below. The first step is the water rinse, as I explained earlier, due to the stamping process. Therefore, the main purpose of this step is degreasing, removing oil, grease, and dust, water rinsing, and pickling or surface activation. Through this step, any metal part that currently has oil or grease will be in good condition. At this point, we are ready for step 2. Let's recall that ED paint has 5 layers. The first and most basic layer, located between the substrate and pretreatment, is phosphate or zirconium. Zirconium is used if the product requires higher quality. To create the phosphate layer, phosphating is used. This is step 2. After completing step 2, because there is still excess phosphate on the product surface, it is necessary to clean the surface with a DI water rinse. The main purpose is to remove remaining phosphate or zirconium from the surface of the part. It also aims to create a phosphate layer with uniform thickness and smoothness. In short, the pretreatment step aims to create a phosphate base layer. After completing this step, we have created a base for the paint to adhere to the metal part. To paint, we begin by dipping the metal part into the paint bath. Therefore, the next step is ED painting. Step 2, ED painting, Electro-Deposition. The product is attached to a jig and immersed in an electro-deposition bath. Based on the ED painting principle we learned earlier, the final result of this step is that the metal part is painted, but only the ED primer layer. Therefore, the ED primer layer is considered the most important layer in ED painting. What about the 3 layers, surfacer, base coat, and clear coat? The truth is they are created by applying a spray painting process and technology. This is another form of painting, only applied when the product requires a high-quality paint finish, such as on automobiles. I will probably share more details about this method later. In short, step 2 produces a painted metal part, which is the ED primer layer. However, when the metal part is removed from the paint bath, we have the problem of remaining binders and chemicals on the surface. Therefore, we need to clean it thoroughly using an ultrafiltration UF rinse. Step 3, ultrafiltration rinse. This step has 3 main purposes. Firstly, surface cleaning, excess paint, ionization, ensuring the ED primer layer thickness meets standards. After rinsing, a large amount of paint and chemicals are collected and reused. So the second purpose is paint recovery. 95 to 98% of spilled paint can be recovered, saving materials and reducing production costs. These reused materials are returned to step 2, ED painting. The third purpose is to reduce deionized water consumption. Thanks to UF circulation, the amount of DI water used for washing is significantly reduced, contributing to environmental protection and reducing operating costs. A typical example is that in factories with well-managed paint systems, the amount of water needed for rinsing is only 30 to 120 L/vehicle, depending on the technology. In summary, after the ultrafiltration rinse, a problem arises. The metal part's surface will still be damp and sticky, and the paint will not be completely dry. Therefore, the next step is baking or curing. Step 4, baking or curing. After being dried at a high temperature of approximately 150 degrees Celsius for 1 to 2 hours, the water vapor and solvent components will evaporate. The result after drying is a layer of paint adhering to the surface of the part. This is also the reason I mentioned earlier why no solvent remains after painting. In short, this step creates the paint layer, but it also has the problem that the product will be hot after drying. So a cooling step is needed to cool it down. After cooling, inspection is carried out. Depending on the product requirements, different factors will be checked. However, the most common checks are paint thickness, paint resistance to physical and chemical agents, color and gloss, and scratch resistance. Ultimately, only after performing these checks do we receive the final high-quality product. So we've explored the ED painting process. In reality, applying this process requires many factors, such as high-quality personnel, knowledge, investment in machinery and paint tanks. For the most complete application, perhaps the ED painting process on a vehicle is the best. It seems I'm starting to sense you still have many questions, such as how to design stamping parts, jigs, how to manage stamping off tools and off process, how to develop quality management, parameter management, quality built-in concepts, cost reduction, and many other questions, for example, ED paint defects, causes, and countermeasures. In general, if you still have many things you don't know, please follow me. I will continue to share everything I know in many more video parts. I hope this knowledge is as useful to you as it has been to me.